Welcome to Run Mode, an industrial automation podcast by mation. I'm your host, Terry Busch. Earlier this summer, we hosted a tech fair at our new fulfillment center in St. Paul, Minnesota. Today's episode features a live panel discussion we recorded at that event. We talked about bringing robotics into a plant to solve workplace challenges many manufacturers face today. I moderated the discussion and was joined by our robotics expert, JD Teter, our safety expert, Jeff Johnson, and our president, Rausch. No matter where you are in your robotics journey, I hope this episode provides you with a practical next step. And now here's my conversation with JD, Jeff, and Al. Thanks for stopping over. Thanks for coming to our event. Hopefully everything's working out for you, food-wise and others. We got a great team here. My name is Terry Busch, the moderator, business development manager for a lot of the things that we have out on the floor, motion, IAOT, controllers. I kind of cover a lot of different topics, and I'll let each one of you guys introduce yourself as part of the panel. And your area of expertise, JD, we'll start with you.
I get to start. JD Teter, I have been with mation for 20 some odd years. I also work for ABB kind of in between. My specific areas of responsibility are motion control, VFDs, and robotics. I don't know if there's anything to say other than I have my good American friend Jeff.
No, my name is Jeff Johnson. I'm with mation now for 9 years. Spent 30 years in the industry as a electrical engineer, designing, developing, and implementing a variety of different control systems for some really great companies. My emphasis is on safety as a business development manager and safety products. So thanks for coming in today.
And I'm Rausch. I'm the president of mation. I'm new in the tenure side of it, so I've probably been here going on 7.5, almost 8 months. So expertise, questionable. I would say from my background's all on the manufacturing side of it, so I've run companies primarily in high industrial manufacturing. And so I come from the perspective of the end user, if you will, in the equation. So I'd say my expertise is more on that side. So if we start throwing too many acronyms out, I'm going to get lost because I'm just starting to know what a programmable logic system is. But bear with me on that. But my expertise would be far more on the manufacturing front. So.
And what we wanted to talk about today is sort of in that robotics journey, we call it. As you kind of imagine yourself walking through a manufacturing facility and you're seeing these different jobs that are out there, and we look at them and say, well, is this a job that's highly repetitive or something that's dull or something that's dangerous? Those are the type of automated systems that we put in place to be able to prevent people from getting hurt and those types of applications. And we really break that down into two areas. Purposefully built motion control, or is it something that we can put in a robotic system, right? So that's one of the reasons why we asked Al to sit in, because he has that background in manufacturing and sees some of those jobs and some of those things that can be dangerous for people to be around or even dull or boring. So didn't know if you wanted to add any?
No, that covers it. We throw out there dull, dirty, and dangerous, right? When someone says, we're thinking about a robotic system, or where do you want to apply robotics, right? Those are the three big ones: dull, dirty, dangerous. And Terry kind of covered them very well with their some examples of some applications we've done are highly repetitive, sheet feeding systems. And we had an operator that was had a process of a printing, and then they had a mid process, and then they had a final cutting process. And so we were able to take that. And they had a hard fix, it's not dovetail to the next one, they had a hard fix system that was feeding the sheets, but the problem they ran into was flexibility on the feeding mechanism. So we talked about it, and then we were able to help them deploy a robot system that removed that gantry system. It freed up at the end of the table, allowed the maintenance team access to some things they have to get into, but at the same time allowed a lot of flexibility in the feeding of the sheet now. And then it freed up the operator too, so she could go back and focus on the quality of the product and the cutting. So that was one of the examples of a highly repetitive process that she was doing. Fed into the dangerous a little bit because she was grabbing material constantly, right? So we were able to help them get a table, come right off one process, roll up to another process, and then have the robot feed right directly from it. So dull, dirty, dangerous are the things that we do.
And so one of the parts of the story that's interesting is the dynamic nature of what they were doing. You build a gantry system, something very fixed, very purposefully built, like in standard automation. When you need to move something from A to B, is it flexible enough where you can then bring in other parts of the system? Can you make it dynamic so you can interact with people? Is it something that can be changed on the fly? Once you build this box to do a specific job, maybe that's the only thing that job can do, and then you decommission it and you do something else. Back in the Wayback Machine, yes, I've been here for a while, 30 some odd years, we did contract packing. So we would build up a line, we would run it, as soon as it was something that was viable and maybe they would want to do it fully automated at their facility, they would pull the lines out and they would bring it back to their facility and we'd do the next one. We would turn a lot of lines that way. Robotics would be a great way to be able to get in there and be dynamic around what we're trying to accomplish from a pick and place or a feeding of a machine. So that kind of brings us to the next, I'll call it broader topic, but the type of robots. And really, the definition is any automatically reprogrammable multi-process manipulator with 3 or more axes is sort of that catch-all for what actually a robot is. So JD, why don't you mention some of the things that we have up on the deck here?
So you could say, if you wanted to go super broad category, industrial side for robotics and cat robotics, actually, right, or commercial robotics. So, the cat is zipping around on a Roomba. That's a type of an autonomous vehicle, right, performing a certain function. So some of the robots we have up on the screen there, kind of break them down into really 5 broad categories. A Cartesian system, like you see up there in the upper left, or a high-speed Delta, the spider type robot, very popular for pick and place systems, for especially in the food and bev industry. The more popular one, the more well-known one, is the articulated one, or the 6-axis. That's the one that is about to drop that bucket on that gentleman's head. Typically not a collaborative application. Let's just go with that. Collaborative robots are like a subset of the articulated robot, and then the SCARA, which is in that lower right? So some very specific type operations there. And then again, we have the autonomous type vehicles.
So now that we've figured out, okay, we've got robots, we have access to this type of technology, how do you apply it? The very first thing you got to do is completely ignore the fact that you have robots and think about what you're trying to accomplish. You're trying to pick up a box, you're trying to move a manipulator, something as simplistic as a welder. Are you going to bring the product into a welder and move it to weld it, or are you going to weld, move the welding wand, right? So those are some of the things you have to think about when you're building out a system. Before you even pick a robot, you got to talk about that.
Yeah, so when we look at an application, a lot of people will look at it and say, well, I'm going to maybe deploy the 6-axis robot. That's maybe not the best way to go. Like Terry said, we really got to look at the tooling. What are we doing, right? The process really becomes key. So we really start to focus on what the end process is, what that end piece is, what kind of tooling that we need up there. And then you'll see on that one example, the end effector, you'll hear that term, right? The part that typically goes on the end of the robot, that becomes part of the robot payload, right? So that's something to keep in mind when we're selecting robots. And then the other thing that comes up is, well, how do we present the parts? And this is what we're showing here. There's a couple different ways. We have a very flexible feeding system that you see there that can integrate a camera and a rotating disc that can bring parts into the system. We have your traditional conveyance type system. We have a portable type system. The cabinet maybe has parts on it. The robot can open up the cabinet, pick out a part, put it into a process. And then the next thing that comes up is like, okay, well, if I have all that, what if I have a randomized product? How do I locate that? Machine vision systems like we have out on the floor there, a MechMine system, where if you go back by the robot, you'll see a MechMine camera looking down at a pallet. So those are a lot of the different things that come in. When we look at end of arm tooling, sometimes they can be, again, if you look at in our fulfillment center out there, right? You'll see some areas where we have a simple vacuum cup, but then you might see something where you've got a full-fledged machine, almost an autonomous machine being held by a robot. So vacuum, gripping, other things going on, right? That end of arm tooling becomes critical. So we look at, well, what's happening? So we have, we're going to be bringing parts in. We're going to be acting on those parts. We got to get rid of those parts. What are some other considerations? Well, do people have to go in and out of the cell? And that's what we're showing here. Well, what else do we have to accommodate? Is that a routine thing? Is that part of the process? Is that just a maintenance person? All these things that we do. So we like to have a very detailed conversation with a prospect on what they need to do. We really want to understand the process so we are better versed in how to provide you a complete solution. And when it comes to that, safety, right, is always forefront for everything we're doing, right? So, and we're looking at how do we bring safety in on the front end versus trying to do it on the back end. I think we're going to kind of jump into that next.
Yeah, and so that kind of brings us into the next conversation, and we're talking about safety. And the big thing about safety is where do you start? And you start with protecting the person, and that's where it gets into kind of Jeff's topic of expertise around the safety side.
Right. So once the overall concept of the robot cell or application has been developed, it's really important to ensure safe design and implementation. And it's critically important, right? So as Terry was saying, how, in my opinion, the most important aspect is, besides the process, is how do we keep people safe? And it really starts with a solid functional safety design that really needs to be upfront in the machine design process, right? And so, not only can we reduce our overall installation costs, but we can also have the opportunity to design out those hazards during the design process, something you're not going to be able to do once that machine hits that floor. So how do we create a functionally safe system? Well, in my opinion, that really starts with a good understanding and knowledge of the applicable safety standards, right? So
Yeah, and a good example of that is if you design a system where there's a person that needs to interact with that process, now you got to design safety around that person and protect them, right? So it could be hard guarding. It could be something where they prevent them from walking in. It could be light curtains and different things like that, and you got to have e-stops. It's much better to design it so that it can run all by itself without anybody in it. You weld a box around it. We have the ability to do that. We can weld a box around things, or we can have people interact with the process to make sure that it's done safely.
the other thing that's really important in developing a safe machine is really the risk assessment process. Risk assessment is there to help identify, evaluate, and mitigate potential hazards. Risk assessment should be a team approach where the overall goal is to create a roadmap so that we can create a safe machine design and meet the requirements of the application safely.
Yeah, and there's a standard 2017-ish OSHA said that all personal, in all workplaces need to have a
The
safety.
employer is responsible to
Yeah.
ensure that the risk assessment process has been validated.
And so that's the documentation that needs to be in place. If somebody gets hurt, or even if they get audited, it's like, hey, I protect it, whether it be chemical splashes, whether it be robots hitting you and different things like that. So that's part of the equation anytime you're building an automated solution inside of a manufacturing facility. And there's areas where the technology is growing quickly, but it's also growing, I guess you could say, safely. Around we have things like radar systems, the fencing.
So some of the things Power Machine provide, first of all, as a Power Machine customer for well over 25 years, one of the things that impressed me the most about Power Machine was their ability to really strategically align with some of the best companies in the industry, providing world-class products and services. So things Power Machine can provide, we can provide training from risk assessments, we can provide training to, if you want to become a certified machine safety expert or licensed machine safety specialist, we can provide perimeter guarding fencing systems, we can provide custom interlock solutions, custom scalable safety relays, safety controllers, presence sensing devices from light curtains, laser scanners. So really just an incredibly deep product offering that Power Machine has, and being able to meet the requirements. Power Machine has a very deep customer base with a vast array of manufacturing capabilities, and having a line card as this really helps us meet the requirements of customers with very specific needs, especially around robot and robot systems, for sure.
So when we think about those kind of things, think about the robots, it's not about the robot itself, it's not about the robots that are out on the floor, it's not about the Roomba vacuuming your floor, or even the autonomous vehicles that are driving around. It's more about how you're gonna apply it, what you're trying to accomplish, what areas are you trying to automate, and then you move into how do you manipulate the work piece, how do you manipulate the robot potentially, in feeds, out feeds, and that. Once you've determined that, then the next step is that safety piece to make sure that if there is somebody interacting, that you do it safely, that you can guarantee that they're not gonna get hurt. And then lastly is the outcome. And the outcome side is what's interesting in the dollar, putting the dollars to it, right? So that's why one of the reasons we asked Al to sit in because of his manufacturing background. Talk a little bit about improving quality, efficiency, and speed and driving down the costs.
Yeah, I think from that perspective, I'd go back to the kind of the two things as a business leader walking into a manufacturing environment where you live today. My mind goes in two ways. One, is the environment safe for employees? Is it an environment where we might be putting them at risk? Either it's repetitive motion or there might be a hazardous environment. So you look at it from a employee welfare component. And that would be in itself justification for some form of automation, robotic systems to protect that environment. And then secondarily, my mind then goes to the ROI, the return on that investment. And so are we either gonna get efficiencies out of it, we're gonna increase speed to throughput, or reduce costs and expense. And then the other component to that is with the huge challenge with labor and technical skill resources coming into manufacturing today. One way to combat that is through automation and robotics, right? Because you can put those systems in place. And Amazon is a good example. The amount of robotic systems that they're investing, putting into their facilities is exponentially higher than most manufacturers because they can't get the resources to the labor. They can't get access to the labor. So, those are kind of from a leader standpoint, that's kind of where I'm going. First and foremost is the environment that our workers are in. Is it a safe environment? Is a repetitive environment, kind of the three categories that you put forward before. I think that's kind of an innate. I think my background might be a little probably out of the ordinary for many. I was at one point in my career a risk manager for a major manufacturer, multi-billion-dollar manufacturer. So my responsibilities was that, right? So I had to know OSHA requirements, I had to know insurance, unemployment, or workers' comp insurance and things of that nature. So now when I go through a manufacturing facility, I have different things running through my head as far as where the costs are. But it's interesting being part of Powermation. I think you're right, Jeff. I think the power in our services and our understanding about what robotics do for you, and how we can bring different services and features to the table to help you get to the answer that you're looking for with the best of industry. Not only knowledge, but product sets is really good.
And when we kind of round that out and we talk to customers, manufacturing facilities, there's many different people that we need to talk to about it. Maybe it's the controls engineer that needs to move a box from A to B, and so he's designing something, let's use a robot, not use a robot. But what about the quality guy? What about he says, you know what, we're getting 10 bad parts out of 100. Maybe we can automate it, better quality. Maybe it's somebody else that comes along and says, he's a manufacturing engineer, and it's ergonomics. Where I came from, it was taking pouches off a conveyor and putting it in a cartoner. And these people would do this with two arms because you couldn't do it with one fast enough. And they would do that all day long, 24/7. Well, they wouldn't do it 24/7, they just 8-hour shifts. But the machine was running like that. We could automate that. If it's something where somebody's just picking up a box off a conveyor, now they're gonna hurt their back. So ergonomics is a big thing. So you've got the quality person, you've got the HR person, you've got the other people in the facility, making sure people aren't getting hurt. And then at the end of the day, you've got a manufacturing engineer or maybe the plant manager that's trying to get yield out, and they're trying to do things very purposefully so they can get things done, as well as, is somebody gonna call in sick today on this dull job? Maybe we should get something in there that automates the process. So, otherwise, we'll let the panel do closing comments, and then we'll.
We really appreciate your time. We look forward to working with you guys, Daryl, myself, Jeff, all of us. Got questions?
Let us know.
Yeah, absolutely. Sales team, they would love to do walkthrough through the facility. That's how we find these dull, dirty, dangerous operations. And one thing that comes up for us, Daryl and I have had this conversation. People say, well, if I put a robot in, am I displacing somebody? No, you're enhancing their marketability, right? And so we've had applications where a person learns a new skill set. So we like to counter that, free someone up to do something else where they learn something. So try to keep that in mind. We're not looking to replace people with robots. We're looking to improve the process and allow the people to grow their skill set.
Any other closing comments, Jeff?
Good.
Covered?
Good.
I would, maybe my comment would be, I think there's a lot to be said about when you're inside your own manufacturing environment, bringing in someone to give you a different perspective. These gentlemen are in manufacturing environments every day. And so they're seeing different applications and coming forward with a different solution. And just having that opportunity to just sit down and say, hey, here's our process, do you see anything? Could be of great value because they see a lot of different manufacturing environments and different applications.
I would like to thank our robotics panel guests and you for listening. Subscribe to our YouTube channel and podcast to stay up to date on future episodes. See you next time.